We will continue explaining waves here because we didn't have enough time in the library using the Blackboard, so we're gonna use it. We're gonna explain it here. We're gonna explain about couple oscillations. In this theme, well, we're gonna have two different types of waves. We have longitudinal waves, longitudinal, and transverse. So the main difference between them is that a longitudinal wave moves in the same direction that the oscillator does. So if, for example, we have, I don't know, like this type of mass and it starts to oscillate and it moves in this way. So, for example, sound, it's type of longitudinal wave. It moves towards the direction of the oscillator, while the transverse wave moves in a perpendicular way to the movement, so to the oscillator movement. So we have, for example, electromagnetic waves and light. So we will have that light is a type of transverse wave. Another thing that we can mention is that, for example, if we have a string, right, and we have ropes that are in, for example, if we move one of these ropes and we create move a change in the position, in the angular position, then this will start to oscillate and will create the others to move in that certain angle. And that's also important part of oscillations. Hi, well, we're going to talk about superposition principle and interference. A superposition principle comes up when we have two waves that cross between each other. For example, we have this wave and we have it moves this way. And we just need to remember that from here to here, this is half of a lambda. So then we will have another wave that moves this way. So the result of these ones will be an extra wave. Okay, well, it is also important. This is the superposition principle, but we also call this, this is like when we have superposition and we create another one, but another wave. But we also could have that interference is when you modify the wave according to other wave that is in the superposition. For example, if we have this wave and this wave goes that way, and we have another wave that exactly moves the opposite direction, then we will have a deconstructive wave. Because the waves will cancel each other. But if we have this wave and then we have another wave that will make the wave larger, for example here, and we have this wave, and the result will be another wave, a bigger wave, then we are saying that is a constructive wave. Hi, now we're going to explain standing waves and resonance. Well, we have standing waves when we have two waves, but oscillate and are exactly the same, but they oscillate in the opposite way. We have this wave and we have the other wave that goes like this. So we're gonna have that each of these intersections is called a node, and here will be called the antinode. Okay, so this is a standing wave, and the concept of resonance is when you have a system and you affect it with another oscillation system, and it drives the other system to oscillate with greater amplitude. This means that the amplitude increases while the other system affects this oscillation. And we will have a specific frequency in which the oscillation would take place.